All of you turn on your cameras, and those who have any problems in turning on their cameras, please inform in the group. Okay, please inform in the help and support group where your problem will be seen. Okay, so let's see here. Here I have one assignment in front of you. We start with topic by topic. So see, the first topic is production and propagation of sound wave, and the second topic is relating to infrasonic, sonic, and ultrasonic frequencies. Okay. So we move to the first topic. The first questions you see, they are very short questions. You have to answer them in brief. In brief, whoever person knows the answer will reply at the same time by turning on their mic. And if you find something like that should be noted, you don't know, you didn't know that, so you should note that down. We will stop over there. You can make a note of that. Okay. So basically, we will be discussing this orally only. Wherever required, I'll also provide you some written solutions to them. So I hope the screen is visible completely to everyone.
Yes, sir.
Okay. See the first question. How are sound waves produced? So anyone can answer. How are sound waves produced?
Through vibrations.
Yeah, sound waves are produced by vibrations or by the vibrating bodies. Then what is the source of sound?
The place from where the sound is produced.
The source of sound is the vibrating object. Okay, any vibrating object is the source of sound. Okay. Then what are requisites of the medium to conduct sound wave? That means how should a medium be to conduct the sound wave?
Sir, it should have particles. It should
Yeah,
not be vacuum without any particles.
yeah, it should have particles, and the particles should be allowed to vibrate. Okay, it should be made up of particles, and the particles should be allowed to vibrate. Then only the sound can travel from one place to another. Okay, like you see about the thermocol. So what's the difference between a thermocol and wood? In thermocol, sound does not propagate that fast as compared with the wood. Okay, that is the makeup of the thermocol, how the thermocol is made up. Now, name the two kinds of waves in form of which sound travels a medium.
Sir,
Yeah,
longitudinal transfer, sir.
okay, longitudinal waves and the transverse waves. I just want. So how are sound waves produced? We have seen source of see whatever you think that you know these questions, but they require a revision. They require some level of perfection so that you get your complete marks. Okay. So we have seen what are the requisites of the medium to conduct sound wave. The requisites of the medium to conduct a sound wave is that the medium should, the particles, it should have the particles, and the particles should be allowed to vibrate. Okay. Name the two kinds of waves in form of which sound travels in a medium. So we studied that longitudinal waves and transverse wave are the two ways through which a sound wave can travel. Okay. Define the following terms related to the motion. So one by one, we'll start with Rishika. First one is amplitude. So
Yes,
Rishika,
sir.
what do you mean by amplitude?
Sir, amplitude is the pitch. It changes the pitch or the shrillness.
No.
It's the length of the frequencies.
Frequency.
No, sir, the length between the crest and the
Sir, can I tell?
Yes, Prince.
Sir, it is a maximum displacement from mean position.
Yeah, the maximum displacement of the oscillating particle from the mean position is called as the amplitude. So as we saw that even in the wave, a wave is also formed by the oscillations of the particles. So over there also we observe the oscillations of the particles. The maximum displacement of the oscillating particle from its mean position is called as a wave. Okay, it's called as amplitude. That's the amplitude. Then the time period. Okay, Harini will answer. What is the time period?
The time period is the time taken for one oscillation.
Time taken for one oscillation. Very good. Rishika, if you know any other answer, so you can reply to that also.
Okay, sir.
It doesn't mean you got one incorrect, so you will not reply. You can. Then the next one is frequency. Siddharth, you are not providing any answer.
Sir, is it the number of oscillations
Yeah, the number of oscillations per second
per
is
second?
called as frequency. Okay, so the number of oscillations per second is called frequency. Then what is wavelength?
Sir, the distance between two consecutive a crest and trough.
Yeah, the distance between two consecutive crests and trough is called as the wavelength. And wave velocity. What do you mean by wave velocity? Okay, I got one response. Okay, Siddharth, you may leave the class and rejoin. Okay, Siddharth, leave the class and rejoin.
Sir,
Yeah.
it is the disturbance in a medium which
Mhm.
propagates with
Mhm.
distance and time.
Yeah, very good. A very good definition of the wave velocity. It is a disturbance in a medium which propagates with distance and time. Okay. So, is there any definition which you need to note down out of the five definitions?
Sir, could you repeat amplitude once again? One more time.
Amplitude, the maximum displacement of the oscillating particle from its mean position. So when you are talking of amplitude and frequency and time period, over there you are not considering the wave, over there you are considering the oscillating particle. Okay. So is it clear? Wave velocity is clear. Wave velocity, wavelength, everything. Okay. Then next sixth one, draw the displacement distance graph of a wave. The displacement distance graph or the displacement time graph, they can be drawn as we had seen in the previous one. Do you remember the diagram of the wave? The diagram of the wave which we drew this. The same diagram, the same variation can be used to show this is the same thing as a displacement. So this upward is the displacement. This is the displacement. And on the x-axis, I am plotting the position or distance. So this is the distance that the wave has propagated. And this one is the displacement. On the y-axis, we are plotting the displacement. Okay. See, this is the displacement of the oscillating particle. Distance is of the wave, the distance that wave has traveled. That is the distance, and displacement is the maximum displacement from the mean position. That is for the oscillating particle. So, the next one, How is speed of sound in gas affected by density? So, does the density of the gas affect the speed of sound? First of all, think. Okay, since the sound wave it propagates through the medium, and hence the particles vibrate with certain frequencies to transfer the wave. Hence, particles vibrate to transfer the energy, right? So obviously you can guess here that the density will affect the amount of oscillation. It will affect the frequency and the time period of oscillation, right? So therefore, the wave speed or the speed of the wave, it will be affected by the density. Okay. So how is the speed of sound gas affected by the density? The more the density, the more will be the speed of sound. So that is why you can see in many books, some of the books they state you that the speed of sound in air is 334. Some of the books they will state that the speed of the sound is 340. Somewhere you will see that the speed of sound in air is 340. Okay, so all of them they are correct depending on the density of air, and the density of air changes with time. Sorry, with temperature. Okay, in winters you can observe that your sound travels a larger distance with a greater speed. But in summers, your sound travels shorter distances with lesser speeds. Okay. So therefore, the speed of the sound is directly proportional to the density. It is dependent on density. Okay, the eighth one, compare speed of sound with speed of light. So how will you compare? When you are asked to compare something, how will you compare that?
Sir, in a tabular form.
Tabular form? See, whenever you are supposed to compare two things, find out their ratios. Okay. So you have to, here in this question number 8, you have to find the ratio of the speed of sound with the speed of light. Okay. So in your notebook, find the ratio of the speed of sound to the speed of light. You have to take the speed of sound as 334 or 340 meter per second. Take it 340 meter per second. Neil,
Sir, I searched it up right now. It was showing 1.1 into 10 to 10 to the power minus 6. I don't know if that's correct or wrong.
you searched for it?
Yes, sir. It was
Where
showing
did you
1.0 and
Okay,
times 10 to the power 6.
find the ratio on your own. You have to put here you have to put here speed. You have to compare speed of sound and speed of light. Okay, so you have to find their ratios: speed of sound and speed of light. Right, like this. So the speed of sound is we got as 334 meter per second. Right. The speed of light is 3 into 10 to the power 8 meter per second. Okay. So you can clearly see meter per second will cancel, and you will have your answer as 334 divided over 3 into 10 to the power minus 8. Okay. Now, if you solve this out, divide this, you get 1.1 into 10 to the power minus 8. Converting it to scientific notation, you get 1.11 into 10 to the power minus 6 meter per second. Okay. So you need not remember this. You should know how to find out the ratios. Okay. So Neil, 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 are you getting the answers to the question? Now, Neil, you will answer the next question. How are the wave velocity, frequency, and wavelength of a wave related? So, this is a very important question. How all these three are related with each other? How are the Neil? Are you able to answer?
No, sir.
So you basically have to tell the formula with which they are related. Basically, you have to tell the formula here. So I expect I have done the formula just a few in the last lecture. Okay, so I have done the formula in the last lecture. Can you do that? Anyone remembers the formula? The speed of the relation between wave velocity, frequency, and wavelength.
Sir, wave velocity is equals to frequency into wavelength.
Very good. Who answered this?
Sir, me, sir. Neelkant.
Okay. So your
Sir, मैं
answer
sir the
is,
books पे.
but from the book, see, you have to remember this one. Why I say this is important, as this is applicable for sound wave, this is applicable for light wave also, this is applicable for all the waves, right? This is the general formula where we see that wave velocity v is equal to frequency into wavelength. This general formula is applicable everywhere for all types of wave. Even if it is applicable for the spring wave also. It is applicable for a wave in a rope also. It is applicable for a sound wave also, for light wave also, everywhere. So that is why this formula will work for you everywhere. Okay. So do remember this formula, wave velocity is equal to. Okay. See the next one. Okay. Anyone got the answer? Explain with an example the explain with an example the propagation of sound wave. So think for it think for it, remember it. You have to draw the diagram also. Okay, so first of all, draw the diagram. Let's first draw the diagram. How the wave travels and how you will explain this. First, draw the diagram for it. Okay, Chavan Kaushik, have you drawn the diagram?
No, sir.
Draw the diagram. Do you think? Do you know can you show that wave propagation?
Sir, do we just draw the same thing, then draw it again, extending? Can you just show me once?
Which one?
For the sixth one, sir.
I will draw it. But do you remember any of them? Prince, have you drawn?
No, sir.
How much diagram have you done?
Sir, 10th question.
Yeah, question number 10.
Uh, Sir, I don't know how to draw it.
Okay, anyone who has drawn? Anyone? Neil, have you drawn the diagram? Harini?
No, sir.
Okay. So I don't think that anyone remembers this. Yes. Anyone remembers how to draw?
So do we have to draw it in a transversal wave?
Yeah, since sound travels as a transverse wave in air, so you have to draw that only.
Okay, sir, one second. Sir, should we draw three diagrams, one for solid, liquid, and gas, how it travels in all three
Let me
mediums?
draw.
Okay, sir.
Okay, see. If you look up your book in the NCRT, you will find this one. See here, I'm showing you the diagram for this. See. Okay, just like the light you have studied for light wave, that for the light also there are laws of reflection. Do you remember the laws of reflection for light?
Yes, sir.
In the similar way, those laws they are also applicable for sound also. Okay, see, this was the diagram that was to be drawn here. See, when a pulse is produced from the source, the air particles they are compressed. Okay, and the region formed over here is called as a compression. So similarly, a region is formed where there are lesser number of the molecules. That region is called as a rarefaction. Okay, so in this way, you will have a compression, a rarefaction, a compression, a rarefaction, so on formed will be there. Draw this diagram.
Sir, first one.
Uh, yeah, either you can draw first or second. Any one of them you can draw. It will take just 5 minutes, draw it. Wrong, students?
Yes, sir.
So when a high pulse is produced, then the particles of air, they are pushed together, creating a region of compression. Okay. And for the answer, okay. So got this answer now? Okay, now will anyone try to explain in his words? Prince, can you explain this in your words? Yeah, Prince, can you explain this in your own words?
No, sir.
No. Why?
Sir,
Hmm.
sir, can you show the question?
Okay, question you want? Here we have question 10. Just wait. Yeah, this is question 10.
Sir, the sound want medium to propagate.
Hmm.
Um, without a medium, the sound cannot propagate. The example are air,
Hmm.
uh, uh, water.
Hmm. But
Uh,
how it propagates? You basically have to explain how it propagates.
sir, by vibration.
By vibration?
Sir,
Okay, very good. Good try. Anyone else can try? Neil, can you try out? Neil, can you try out to give the answer?
So can I try?
Yes, Rishika, you can try.
Sir, when a sound is produced in a medium region of high pressure and low pressure is formed, which is a compression and rarefaction, which cause density variations. Sound can only be propagate in solid, liquid, and air, but it cannot propagate in a vacuum without any particles.
Okay, so your half the part is very good, and the later half is a little bit missing. Over there,
Okay.
you just need to add one line that sound travels the regions of high pressure and low pressure. They propagate through the air. Okay,
Okay, sir.
and hence the sound wave is propagated as a vibration in the medium. Okay, so I think I shall give you this question as the homework to write down. Okay, I hope you will try out. You know the answer, you have learned this answer. Now you need to try it out. Okay, so either you can take the help of book or anything, then try to answer this question. Explain with an example the propagation of sound in a medium. Okay, so note this down also. You will also be provided this in the PDF. but do have a note of this. You also have to make the diagram. Okay, let's see the next one. 11th one. Name two kinds of waves in form of which sound travels in a medium. So sound can travel in which two forms in a medium?
Sir, transverse and longitudinal waves.
Okay, it can travel as a transverse wave or longitudinal wave. Can sound travel as a transverse wave also?
Sir?
Can sound travel as a transverse wave?
Yes, sir.
Mhm. Okay. Sound
So
cannot
what's
travel as
the
a
difference?
sound cannot travel as a transverse wave. Sound can travel only as a longitudinal wave.
So a transversal wave is basically like a line which passes through like 2 points. So
No.
how
See,
that's what a
transverse wave. Okay, I think I explained you with the help of the this diagram. Just wait a minute. I explained this the same thing with the help of the image, the oscillations or the waves in a spring, right? Do you remember these two types of waves?
Yes, sir.
Yes, sir.
Okay. See what is happening here. The spring is oscillating perpendicular. It seems to you something is traveling, but nothing is traveling. If you just observe at one point, okay, just can you observe the where the finger is pointing?
Yes, sir.
Where the finger is pointing. So at that point, you will observe the spring first moves up, then moves down, and then comes to its mean position. Is it happening like this?
Sir, that's
Observe.
called a crest and trough, right? So, can a
Yeah.
sound travel?
No, sound is not traveling like this. Sound does not travel in the form of transverse wave. It only travels in the form of longitudinal waves. Okay, the lower one. So what is happening over here? Understood, Chavan? The first one.
Yes, sir.
So
There are
that is a
three types of wave, right?
okay. Which are the three types of waves?
I know transversal, longitudinal, and which other one was there? Are
Okay,
these
see, these are on the basis of the propagation. The other types of wave, they are on other basis. Okay, on the other basics, like you have the electromagnetic waves. They are not matter waves. So you can say there are matter waves and non-material waves. So understood, in the second one, you observe the wave is propagating parallel to the oscillations. If you observe at the finger, only at the finger, if you observe only at the finger point, you observe that the first spring gets uh, rarefaction and then it have a compression, then again comes to its original position. Okay. Now see the next question. So here you write your answer as sound as a longitudinal wave only. Then how is the frequency of a wave related to its time period? Okay. So how is the frequency of wave related to the time period? Can you give the formula for the frequency and time period?
Sir, frequency equals 1 by time period.
Yeah, frequency equals 1 over time period. They are reciprocal to each other. So write the formula. Then what is a transverse wave? In which medium, solid, liquid or gas, can it be produced? Where can it be produced? Can it be produced in a solid or a liquid or a gas? Okay, first of all, define the first. What is a transverse wave?
Sir, transfer waves
Hmm.
can propagate through vacuum
Hmm.
and they did not require a medium to propagate, and they produce in liquid
See,
liquid
they
medium.
can be produced in solid as well as liquid.
Hmm.
Okay. If you observe that we studied in the case of water how the
Yes.
wave propagates in water. Okay. So over there we observed that the oscillations are produced like this. The water particles they vibrate up and down, and the wave propagates sideways. Okay. So transverse waves are the waves in which the vibrations of the particles are perpendicular to the vibrations of the wave, perpendicular to the direction of wave propagation. So everyone noted this answer. Anyone who needs to note down the answer can note down. And if you want any explanation again, I can provide it. I can also write that so that you will be able to write it. But do inform if you require that. Explain the terms crest and trough in relation to a transverse wave. Okay, so your definition will remain the same. Okay, what is a crest and trough? That same thing you have to write here. And I'll ask now Neil. Neil will answer. Neil, Neil, can you answer? Neil, okay. Siddharth, Siddharth, can you try to answer? Siddharth, Harini,
Yes, sir.
okay. So answer this. Okay, Siddharth is having mic issue. Fine. Explain crest and trough. The vibrations of the particle above the mean position are called as a crest, and the vibrations of the particle below the mean position are called as a trough. For example, in the case of spring, we observe the wave like this.
Okay, yes, so when there are the waves, the upper wave is called the crest, and then
Crest,
like down thing is called
trough. So that is what you have to speak. Then flash of lightning reaches us earlier than sound thunder. Why it happens? If you see any sound thunder occurring, if
so
you see any
because
thunderstorms, so you will first see the splash of light, and then you will be able to hear the sound of the thunder. Why it is like that?
light travels faster than sound.
What travels? Heat or light?
So light travels faster than sound, so light will be seen first and then sound will be heard.
Okay. So light travels faster than sound. Therefore, first of all, we see light and then we see sound.
So the speed of sound is 334, while the speed of light is 3 into 10 power 8, which is greater than the speed of sound.
Yeah, it's much greater than the speed of sound. So that is why we first see the lightning and then we hear the sound. Okay. Then we'll leave the other two questions, or if you can answer that, very good. You can leave that. Okay, there is no atmosphere on moon. Can you hear each other on the moon's surface?
No, sir, because there's no particles vibrating.
Yeah, there are no particles vibrating, so you cannot hear each other. Okay. If you place your ear close to an iron railing, which is tapped some distance away, you can hear the sound twice. Explain.
So once while the vibrations pass through up and then when they come back again, you hear it twice.
No. Again, think if you place your ear close to an iron railing, which is tapped at some distance away, you hear the sound twice. Okay, so that's correct. First of all, you hear the sound wave traveling from the source towards you, and then second is the wave which comes to you after reflection from the boundary. Okay, from the railing, suppose if you have a railing like this, let's draw a railing. So you have a railing like this, and if suppose you are hearing over here, if someone taps here, so sound will travel like this, and it will from here it will get reflected back and again come back. So you can hear the sound twice. Or there are other ways also by which you will be able to hear the sound twice. See, the other way is that first of all you will hear the sound propagating through the railing, and the second sound you will hear the sound that traveled through air. Okay, so you will hear both the sounds. First of all, sound through the railing, and the second sound you will hear will be through the air. Then the sound of explosion on the surface of a lake is heard by a boatman 100 meters away and by a diver 100 meters below the point of explosion. So who would hear the sound first?
So
The
the diver
boatman.
will hear first.
The diver will hear the first as the speed of sound is faster in water. So he will hear the first. Okay, second one, give reason for your answer in part 1. So that we have already given. And third one, if sound takes time t to reach the boatman, how much time approximately does it take to reach the diver? Okay. So can you compute it?
So you just posted in WhatsApp. The class time is almost done. Like, send a few questions in WhatsApp.
I'll be sending you. I'll send you up to question number 22. Or shall I send the all?
So
There
send
is
all of them.
okay, so I'll send all of them. You please solve the questions at least up to 20.
So is it 3.4 seconds?
The question, no, you don't have to find it in actual time. You have to find it in terms of t.
Oh, okay.
Okay, the t is already given. You have to find that in terms of t. Okay. Neil, you are not responding to any answers. Are you also not able to communicate? Okay. See question number 22. Describe a simple experiment to determine the speed of sound in air and what approximation is made in the method described by you. Okay, first of all, tell me, is there any method by which we can compute the speed of sound wave? You can use it to compute or calculate the sound wave speed in air. Anything you can try out. Okay, let's move to some of the numerical questions right now. I think I shall leave these questions and you'll practice them. Let's do some of the MCQs we have, and we have some of the numerical problems. Okay, see. A source of wave produces 40 crests and 40 troughs in 0.4 seconds. What is the frequency of the wave? Okay. So need to understand this question. Let's see. Once you have the understanding of the topic, you can do. Okay. A source of wave produces 40 crests and 40 troughs. So how many oscillations are there? What is the number of oscillations?
Say 40.
40. We know the number of oscillations as 40. And what is the time?
0.4 seconds.
0.4 second. Very good. So can you find out the time period?
Yes, sir, by F equals 1 by time period.
But we do not know F. F is what we want to calculate. So how do we complete the time period? See, again, the same question. I have done it in the last class. You are given number of oscillations. You are given the time. Find out the time period. Write the word statement and then find it. Unitary method. It's the unitary method which we solved. Anyone has got the answer? We write the statement like this: time for 40 oscillations. Time for 40 oscillations कितना है? 0.4 second. And you have to give the time for one oscillation is what you want. That's the time period. Okay. So this will be equal to 0.4 divided by 40 seconds. This is the time period. And what will be the frequency? Frequency will be equal to 1 over time period. So it will be 40 by 0.4. And this is equal to 100 hertz. Every time the same thing you are stuck in. Now see the next question. A boy fires a gun and another boy at a distance hears the sound of fire 2.5 seconds after seeing the flash. If the speed of sound in air is 340 meters per second, find the distance of flash from the observer.
Sir, speed equals distance by time.
Yeah, speed equals distance by time. So obtain the answer.
1 second, sir.
1 second.
No, sir, I'm
Obtain
just
the-
I'm just doing the
Okay,
calculation, sir. 1 second.
okay. So apart from this, I'm adding some of the question numericals also for you to be done during the homework. Okay. So I basically I'm sending you the homework part. Okay. So this question number 10 and these question 3, 4, 5, and 6, they are for your homework. Okay. So bye everyone. See you
The
again.
distance 850.
Distance is how
8
much?
850,
8,
sir.
oh, 850. Fine, it's correct.
Okay, sir.
Okay, bye everyone. I hope you will do this question and submit and show it to me in the next class. I'm sending you this homework. Okay. We have done one question, 2. You need to do 3, 4, 5, and 6. Okay. Prince, what happened?
Nothing.
Okay. So this will be available in the PDF of the class. Okay, bye everyone.
Thank you, sir.